Stoichiometry in the real world, better known as limiting reactants. How can we actually use stoichiometry in the real world? Or rather, what real world situations? Up until this point, we have actually been dealing with stoichiometry in ideal situations. So the first thing we need to talk about are limiting reactants. I like to use a cooking analogy. That's just the way that I like to kind of portray chemistry. Chemistry is cooking, or a lot like cooking, and cooking is chemistry. Limiting reactants, there are certain things that limit the amount of stuff that we can make, or stuff we can produce in both a chemical reaction and in a recipe. If you go to your kitchen and you look in the cabinets in the pantry and look for stuff to make a peanut butter and jelly sandwich, this is what you got. You got 4 slices of bread left, 1 full jar of Jif peanut butter, and a half jar of grape jelly. Hopefully it's Welch's. Alright? Now, how many sandwiches can I make? Well, a jar of peanut butter is going to make a lot of peanut butter jelly sandwiches, as well as a half jar of jelly is going to make a lot of sandwiches. What's limiting us to the amount of sandwiches is the bread. If we have 4 slices of bread, we can only make 2 whole sandwiches, or, like I like to eat a peanut butter jelly sandwich, we can only make 4 half sandwiches. So, what limits us is the bread. What we're probably going to have left over, or we'll have in excess, will be the peanut butter and jelly, and will be the peanut butter and jelly. So let's apply this to a real world situation, and let's get us some definitions first. Okay, the limiting reactant is the reactant. Remember, reactants are found on the left side of the yield sign. Is the reactant that is completely used up in a reaction. And this determines the amount of product, okay? The limiting reactant is the one that we completely use, and it tells us the maximum amount of product that can be produced. The excess reactant is added to ensure that the other reactant is completely used up. We try not to ever use exact proportions. We always want to have an excess reactant that way we know that the reaction went to completion. The excess reactant is typically cheaper and easier to recycle. For example, if you're working with platinum substances, as I have in the past, you typically don't let platinum be your excess reactant, because your excess reactant, remember, you're going to be using more than what you need, and platinum tends to be a very expensive reactant, so you would want to use a cheaper reactant. So the steps to limiting reactants. The first thing we must do is, of course, write a balanced equation. Then, for each reactant, we must calculate the amount of product formed. For each reactant, so for each different compound or molecule located on the left side of the yield sign, we must calculate the amount of product formed. Step 3 says the smaller amount of product formed indicates the limiting reactant as well as the amount of product. So let's look at a real world situation. It says 79.1 grams of zinc reacts with 0.90 liters of 2.5 molar hydrochloric acid. Identify the limiting and excess reactants. How many liters of hydrogen are formed at STP? Well, this is a big involved problem with several different conversions. Okay? First step is to determine a balanced chemical equation. We have a balanced chemical equation here. The second thing we must do is identify the limiting and excess reactants. Well, that means we have to solve for both the reactants. So we're going to have to solve for zinc, determine how much product can be produced, and determine how much product can be produced from hydrochloric acid. Our unknown is liters of hydrogen. Now, remember, we have to go from moles of liters of the gas by using the molar volume, which is a constant in this chapter. What we have, and what we're starting off with, are our knowns. We have 79.1 grams of zinc and 0.90 liters of 2.5 molar hydrochloric acid. In limiting reactant products, you're always going to have more than one known. You will always have more than one known. Each known, you have to set up a different set of dimensional analysis boxes. Now, let's start with the zinc. All right. We know that we are starting off with 79.1 grams of zinc. We have to go from grams to moles. We do that by using the molar mass in the periodic table. Grams of zinc, of course, cancels. Now we're in moles of zinc. We have to go from moles of zinc to moles of hydrogen, okay, because that is our unknown. Remember, we use the mole ratio to go from moles of one substance to moles of another substance. In this case, we have to go from our known to our unknown. All right, so moles of zinc cancels. We're now in moles of hydrogen. Now, we have to remember how to go from moles to liters. Remember, at the beginning of this chapter, we talked about the molar volume being a definition. The molar volume is 22.4 liters of a gas per 1 mole of that gas. Remember, moles of hydrogen is now going to cancel because it is divided out. Multiply the top boxes, divide by the bottom boxes. We have 3 significant figures. We end up with 27.1 liters of hydrogen. So, from 79.1 grams of zinc, we can produce 27.1 liters of hydrogen. Now, we need to determine how much hydrochloric acid we have. That's going to tell us, going to give us a different proportion. In order to do that, we must start with 0.90 liters of hydrochloric acid. In order to go from liters of a solution or liters of a liquid, we must use molarity, which allows us to go from liters of a solution to moles. And the molarity that we were given is 2.5 moles per 1 liter. Okay, liters are going to cancel. We're now in moles of hydrogen. Hydrochloric acid rather. We have to go to moles of hydrogen. We go from moles to moles by using the mole ratio. Every stoichiometry problem has to have a mole ratio, and we get that from our balanced chemical equation. For every 2 moles of hydrochloric acid consumed, we produce 1 mole of hydrogen. Hydrochloric acid has to go in the bottom so that it will cancel. We're now left with moles of hydrogen, but it's asking us how many liters of hydrogen. Again, liters of a gas, just like we did in the previous stoichiometry problem. We have to go from moles of hydrogen to liters of hydrogen using the definition 22.4 liters per 1 mole of that gas. Moles of hydrogen will cancel. Multiply the top numbers, divide by the bottom numbers, and we end up with 25 liters of hydrogen, which is actually a smaller amount. So if we look at it, in a reaction, 27.1 liters of hydrogen can be produced from the zinc. Only 25 liters can be produced from the hydrochloric acid. So the least amount, or the lesser amount, is the hydrochloric acid. So we call that our limiting. That limits how much hydrogen gas can be produced. That's the most we can produce. The excess reactant is everything else, and that's zinc in this case. And the amount of product formed is also always equal to the amount that the limiting reactant can produce. Now remember, these are theoretical calculations. Okay, so we would have leftover zinc in the bottom of our test tube. And that concludes the discussion about limiting reactants.